Kia ora koutou. This video is for Naomi and anyone else who was in the FAST group working on level 2, moving on to level 3 over November and December. So in this video, I'm just going to do 2 questions from the worksheet on trig equations, and I'm going to do them really slowly using the graph and not using general solutions. So if you're watching this and you're doing level 3 and you already have a good understanding of all of the features of graphs and how to use general solutions, you're probably going to find this video a little bit too slow, but I want to make sure everyone knows the solving using a graph approach first before we start to look at general solutions. During this video though, a few things about the features of graphs are going to start to fall out. Okay, so we've got 2 questions here, and the first one just asks us to find all of the solutions to this equation, and we want the values of x that are between 0 and 180 degrees. So things to notice in here, straight up, is that we don't have sine of x. We have sine of 3x minus 15. And that means that the period and the features of the graph are going to be a little bit different than our basic sine of x graph. But we're going to start by changing this over by saying let u equal 3x minus 15 degrees, and then we're going to solve the equation sine of u is equal to 1/2. Then we'll work backwards to find the x values, being really careful to make sure that we just include the ones between 0 and 180, but that we get all of them in. Okay, and at the end I'll show you the graph both for sine of x and the graph for sine of 3x minus 15 degrees. The second question is similar. It looks worse, but we just have a little bit of rearranging to do before we start. Okay, so let's look at question 1. Well, I've already said let u equal 3x minus 15 degrees, but we'll do it again. So that gives me sine of u is equal to 1/2. Now I'm going to put a degrees sign in there as well. The default setting is to use radians, so if I'm using degrees I really should say that. And now I'm going to draw a sketch of my basic sine function. So here it is. This is 0, this is u, and when I'm working in degrees, this point here is 180. So the period of the sine function is 360 degrees. We're trying to find the values of u that give me sine of u equals 1/2. So we take our ruler and we whack in a line somewhere. I'll just try and change the pen colour. Here we go. Right, so my first value is here and my second value is here. Now sine of u equals 1/2 is one that we should recognise comes from a special triangle. So my first solution here is going to be 30 degrees. And by symmetry, the next solution is going to be at 180 take away 30 degrees, right? So we move in that way and then we move back this way. Right, so we've got u is equal to 30 degrees and u is equal to 150 degrees. Let's go out further though and see what other solutions for u we're going to get. Well, we've got this first one here, so we know that we get another one when we add on 360 degrees. So I'm going to put that one down there, and we know that we get another one if we added on 360 degrees to 150 degrees. So 360 plus 150 gives me 510. Now the beautiful thing about using the general solutions method is that all of this stuff kind of happens automatically and faster. But it's really, really important that you understand from the graph what's going on before we start doing that. So I really like this slow approach using a substitution to start us off. But definitely the thing to watch for here is missing solutions or putting in extra ones that are outside the value. Because now we've got our u solutions, we still have to get our x solutions. So 3x minus 15 degrees is equal to 30. That gives me 3x is equal to 45 degrees. X is equal to 15 degrees. So that's the first one, and it's between 0 and 180. The next one, same kind of thing. 3x minus 15 is 150 degrees. 3x is 165 degrees. So x is equal to 55 degrees. So that's good. Now, I think most students doing this probably would just have done those two to start with, but hopefully then you go back to the start of the question and you go, oh, hang on, I need to look for all of the values between 0 and 180. So maybe when we keep going, these ones are still going to work, right? And the reason that's happening, obviously, is because we're dividing things by 3. So let's try 3x minus 15 is equal to 390. We get 3x is equal to 405. So x is equal to 135 degrees. So yes, that one is a solution, and it's important that we don't just forget to put it in. And let's try the next one as well, which is 510. That noise in the background is my dog, because I had to chuck her outside. She was asking for dinner at like 12:30 in the afternoon. So sorry for the background whinging. Right, there we go. So we've got 4 solutions. You can see that that one is getting really close to 180. So that tells me that we're done. What I want to do now, though, is to start to show you what the graphs look like of those 2 functions. So we've got sine of x, which we're confident with. And then this next one is sine of 3x minus 15 degrees. Now, we could just focus on that 3, but instead we could rewrite it as sine of 3 times x minus 5 degrees. And it's a really good idea to get used to factorizing like that early on. What we've got going on here is a horizontal shift of the function by 5 degrees to the right. And then we've got a squishing of the function, so a reduction in the period of the function by a factor of 3. So that means that when we look at that all put together, the new graph looks like this. You can see that we've got this point here is at 5 degrees, and we get one full cycle of the function is now 360 over 3, which is 120 degrees. So this graph here of sine of 3x minus 15 degrees means that I can read the solutions directly off this. Just need to go to here, and you can see that they match up with what we got. Okay, but we did it a slow way on purpose. I'm sorry if you found it painful. Right, let's go back to the second question. So the second one is very similar, so I'll go a little bit faster with it, but it's got this funky bit at the start, which is that it's not in a really obvious solving place yet, because we have sine of 2 theta here and we've got it down here. But this is just a little bit of kind of year 9 or year 10 algebra. We've got sine of 2 theta is equal to 4 sine 2 theta, take away 1. We can treat these as like terms, and we can add 1 to both sides. So we get 1 is equal to 3 sine 2 theta. So finally, I've got an equation to solve, which is 1/3 is equal to sine of 2 theta. And then off we go again with our substitution. We let u equal 2 theta, and then we solve sine of u is equal to 1/3. So here's sine of u, 1/3. Let's see our first one. So 1/3 is pretty low. There's my first value there. This is not a nice number. So u is equal to the angle whose sine is 1/3. Now that comes out as 19.471 degrees. So we're still working in degrees. And by symmetry, I'm going to get this one here will be 180 minus that. Now we can solve, and we get 2 theta is equal to 19.471 degrees. So theta is equal to just 9.7 degrees. Notice, by the way, that I didn't round that too hard because I'm going to go on and do stuff to it. And the other one gives me 2 theta is 160.529. So theta is 80.3 degrees. So we've got those two. But we should check the next one. So we're looking for theta between 0 and 180, but this is u, not theta. So this value here is 19.471. This one out here will be 379.471. So off we go again, we'll try it, and we'll see, well, you can see straight away it's not going to work. So 2 theta is equal to that. Theta works out to be 189.7, which is too big. So that's not a solution. So that one is, and that one is. Okay, Naomi, there you go. There's the first couple done. Hopefully that helps. I'll do the question 7 and question 12 from the worksheet later on. Guys, please just send in any questions you've got. I've got a bit of time now that I've had a break, so I can do a few videos and I'll post them onto Google Classroom. And just remember, if you are watching this from next year's 13 MCA class, this is really important that you understand this method slowly before you race on to solving them quickly using general solutions.